Okay, good evening all of you, my dear students. So today my topic is circle, a very important topic on geometry. So circle is basically actually the geometry chapter. It actually it is the second important chapter. In the last class we talked about straight lines, right? We will talk about pair of straight lines also. So let us first find out the definition of the circle. A circle is the locus of a point which moves in such a way that its distance from a fixed point is constant. The fixed point is called the center of the circle and the constant distance the radius of the circle. So circle is the locus of a point such that, so this is the locus suppose, and this is the fixed point, this fixed point. So you look at that, its distance from the center is always constant. So this is called the center of the circle, and the distance is actually the radius of the circle, the constant distance. So that makes the circle, and this is the important definition of the circle. So if you define, it is a locus. It's simply a locus. This is the point. The point can be here, the point can be here. So this is the point, movable point. In such a way, it will move in such a way that its distance from the fixed point is constant. Next, let us see, this is the example. Suppose HK is the center of the circle and A is the radius. So what is the distance and what is the equation? The equation can be written as x minus h whole square plus y minus k whole square equal to a square. So look at that, the center is given by hk, c is the center of the circle, and xy is any point on the circumference of the circle. So distance between, so p is any point p. So distance between p and the center is given by this formula. You know that formula, x minus h whole square plus y minus k whole square equal to a square. A is the radius of the circle. So that gives you the equation of the circle with center hk and radius a. So this is the equation of a circle with center hk and radius r. Okay, and in particular, if the center is at 0 0 origin and the radius is r, the equation will be simply x square plus y square equal to r square. Look at that, the center is at 0 0 and radius in this case is a. So this is the circle, two-dimensional. Actually you are doing two-dimensional geometry. So this gives you the equation of the circle as x square plus y square equal to a square. So this is the simplest form of the circle if the center is at 0 0 and the radius is a. So that is the particular case of the equation of the circle. Next, what is the general equation of a circle? If I talk about a general equation of a circle, the general equation of a circle is given by x square plus y square plus 2gx plus 2fy plus c equal to 0. Why? You see that you have this equation. I was talking about this equation. So if you expand this equation, you will have x squared plus y squared minus 2hx minus 2ky plus h squared plus k squared minus a squared equal to 0. So you look at that, if you expand this expression I was talking about, the first equation of the circle, then this can be written as x squared plus y squared minus 2 times hx minus 2ky plus h squared plus k squared minus h squared. So hk are the constant because you know the center, and a is also constant. So only variable is xy. So this equation in terms of xy. So this is the general equation of the circle, and this can be written as x squared y squared plus 2gx plus 2fy plus c equal to 0. So what is the center? Center in this case, the general equation of the circle, this is the general equation of the circle. So in this case the center is minus g minus f, and the radius is root over g square plus f square minus c. Why I am writing center as minus g minus f? Let me explain that one. Suppose I am writing x square plus 2gx plus g square. Try to make a whole square actually. That is why I took g square plus y square plus 2fy plus f squared, okay, equal to, so you have taken g square plus f square extra term. So on the right hand side I am writing, to nullify g square f square, I am writing g square plus f square, and c was there, so I am writing minus c. You look at that, your left hand side is a x plus g whole square. So left hand side you can write x plus g whole square plus y plus f whole squared, and right hand side you have root over g squared plus f squared minus c whole square. Clear? So this gives you the equation of the circle. This is in the form of the circle actually. This gives you the equation of the circle. Because you look at that, the first equation of the circle is given by x minus h minus y minus k whole square a square. So you have a x plus g, that is why center is given by minus g minus f if your equation is in the general equation form, and the radius is given by g squared plus f squared minus c root over, provided that g square plus f square greater than equal to c, because it's a positive real number always. So this is the center and this is the radius. Now there are a few cases about that. If g square plus f square minus c greater than 0, then the radius of the circle will be real. Yes, obviously, because g, f, c are constant. So you will get a real number in that case. So in that case you will get real circle. But if g square plus f square minus c equal to 0, if this value equal to 0, then the radius of the circle will be 0. In that case you will get a point circle. That is called a point circle, a point, no radius actually. And if somewhere in your calculation g square plus f square minus c is less than 0, negative, under square root if it is a negative, that is called a imaginary circle. Okay, so there are the three cases. Next I will talk about a very important concept, general equation of second degree. Actually, where did you get that general equation of a circle? From where it is derived? I was talking about that. So you look at that, general second degree equation can be written as ax square plus twice hxy plus by square plus 2gx plus 2fy plus c equal to 0. This is called the general second degree equation, second degree general equation, or general equation of second degree. So this will represent the circle only if there are two conditions for that. One is coefficient of x square must be equal to the coefficient of y square if it is a circle, that is a equal to b, and there won't be any term having xy, so coefficient of xy is 0. Coefficient of xy is 0 and coefficient of x square must be equal to the coefficient of y square. So look at that, your general equation of second degree is given by, general equation of a circle is given by x square plus y square plus 2gx plus 2fy plus c equal to 0. So they look at that, coefficient of x square is 1, coefficient of y square is 1, and there is no term involving xy. So this is the condition that general equation of second degree represents a circle. Next, I will talk about some particular cases a very important case you will find while you are solving the problems. When you will encounter with the problems, you will solving some problems, you will have some cases. So I will talk about those cases. First case is that equation of a circle passing through origin and center be hk. So look at the diagram. This is the circle and it is passes through the origin. This is your origin and this is the center C hk. So in this case, your straight you have a result. If r be the radius, h square plus k square is equal to r square. Let me magnify the diagram. Maybe it is not possible for you to visualize the diagram. So this is the case. Okay, sorry. Let me draw the diagram once again. So this is the circle, suppose, and no, it is not passes through the origin. It is very difficult to draw the circle with the mouse. Yeah, suppose this is the center. This is the origin O and this is the center C hk. So this is the radius r and this is perpendicular. So this distance is h, this distance is k. So h square plus k square is equal to r square, or the distance of the center from the origin is h square plus k square, and that is equal to r square. So if you substitute in the general equation of the circle, you will get this result. This is the equation of the circle: x square plus y square minus twice hx plus minus twice ky equal to 0. Because you have the center as hk, so x is x minus h y minus k whole square equal to r square, and if you substitute h square plus k square is equal to r square, you will get this type of relations. Okay, so this is the case when the circle passes through the origin and center is hk or alpha beta maybe. Okay, next case. What is the equation of a circle whose center lies on the x-axis, lies on x-axis? It should be x-axis. It should be x-axis and circle not passes through the origin. Circle it not passes through the origin. You look at that. This is your x-axis and suppose this is your h0, because k will be 0 in y-axis. So your center will be x minus h comma 0 is the center. So your equation will be x minus h whole square plus y square equal to r square. R is the radius. Suppose r is the radius of the. So this is the equation of the circle when the center lies on the x-axis. Next case, equation of a circle passing through the origin and center lies on the x-axis. Now the case is that circle passes through the origin and center lies on the x-axis. Okay, in that case your h k will be 0. So this is your h 0. So you look at that, this distance is h. So h equal to r, actually mod h equal to r. Okay, mod h, it can be that side also, negative side also. So mod h equal to r. So your equation of the circle reduces to this form. This is the case when the circle passing through the origin and center lies on the x-axis. Next, equation of a circle which touches the x-axis. If the circle touches the x-axis, then what is the equation? In that case, if it touches the x-axis, then the center will be just above the point of contact. This is the tangent. That means x-axis is the tangent. This is called the tangent of the circle. So x-axis is the tangent. In that case, your center will be just above the point of contact. So in that case, your radius will be k, because k is the or ordinate. So ordinate will be the radius. So radius equal to k, and the circle equation of the circle can be reduces to this form. Okay. So this is the equation of the circle. Next, I suppose this is the last case. When the circle touches both the axes, what will be the diagram? So look at the diagram. This is x-axis, this is y-axis. If the circle touches both the axes, this will be the diagram. In that case, your center will be HH. Why? Because x-axis and y-axis both are the tangents, and the point of center will be just above the point of contact. So this distance will be h and this height will be h. So equation of the circle reduces to this form. If you simplify, you will get the simplified result. So this will be the diagram when the circle touches both the axes. Okay. Now I will talk about some important results. Equation of a circle whose diametrically endpoints are given. Suppose this is the circle. In the diagram, look at the diagram. A and B are the points. A point, the coordinate of A point is x1, y1, and coordinate of B point is x2, y2, and this is the coordinate axis, x and y, two-dimensional. So P is any point on the AB is the diameter. Remember, AB is the diameter, so diametric endpoints are given, and P is any point on the circumference of the circle. And you know that angle in a semicircle is 90 degree. So APB is 90 degree. So you know that if it is a 90 degree, then the slope of the line PA, product of the slope of the line PA and product of the slope of the line PB is equal to -1. So the slope of the line PA is y minus y1 by x minus x1, and slope of the line PB is y minus y2 by x minus x2, and that equal to -1. The product equal to -1 gives you x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. So this is the equation, and you can use this result. If you don't remember the result, you can use the result that angle in a semicircle is 90 degree, and from that result you can get the equation of the circle whose diametric endpoints are given. So this is a very beautiful result for the circles. Next, I will talk about position of a point with respect to a circle. So look at that, P is a point and C is the center of the circle, and suppose if P is any point on point x1, y1, and S is the general equation of the circle. If you substitute the point on the circle, if the S1 means if it satisfies by the point, if S1 is greater than 0, point P lies outside the circle. If S1 is equal to 0, P lies on the circle. If S1 less than 0, P lies inside the circle. Okay. So these are the results. You can verify whether the point is inside the circle or on the circle or outside the circle by this criteria: S1 greater than 0, S1 equal to 0, and S1 less than 0. So these are the results. And you can check with the center also. You can check the distance as CP, the center, the distance of the point from the center. If CP is greater than 0, if CP is equal to 0, and CP is less than 0, you can get the same conclusion. Now I will discuss about the this is the last section of my talk today. So this is the I will talk about the position of a line with respect to a circle. This is a very important topic. So you look at that. See, this is a circle whose center is minus g minus f. This is the general equation. If this is the general equation, you know the center is given by minus g minus f. Okay, this is the center, and L be the straight line Lx plus my plus n, and Cm be the perpendicular distance from center to the line. You know how to draw the perpendiculars and how to get the perpendicular length of the perpendicular, and R is the radius of the circle. So look at that in the diagram, Cm. So Cm. So there are three possibilities actually. The straight line can intersect the circle, the straight line can touches the circle, or the straight line neither cuts nor touches the circle. So these are the three possibilities for the straight line. So if CM less than R, look at the condition, the line cuts the circle at two distinct points. In that case, this is called the chord. If CM equal to R, then the line touches the circle. This is called the tangent. And if CM greater than R, neither chord nor touches the circle. This is imaginary tangent actually. So these are the three possible cases. And what is CM? CM is the perpendicular distance from center to the line, and R is the radius of the circle. Okay. Now we can deal this result in a different way. What is a different way? Let me discuss position of a line with respect to a circle. So suppose this is the circle, your circle equation of the circle, suppose the equation of the circle is x square plus y square equal to I have chosen a square. Okay, let the circle be a square and let the line be y equal to mx plus c, simplest form, and y equal to mx plus c be the straight line. Then what I actually did, I have solved these two equations. Solved means I have eliminated y between 1 and 2. This is equation 1 and this is equation 2. So if I eliminate, then this equation can be written as y, replacing y by mx plus c equal to a square, right? You look at that. Okay, and if you expand, you will have a quadratic in x. If you expand just like this, a plus b whole square, so this is m square x square plus c square plus twice mx c equal to a square. You look at that, you have a quadratic in x. Look at that, you have a quadratic in x. This is the expression that this is I was talking about. This is quadratic in x. So this is the quadratic equation. So a is given by this, b is given by 2mc, and c, the constant term, is given by c square minus a square. So your discriminant is b square minus 4ac. So if there will be three cases for the discriminant: d greater than 0, d equal to 0, and d less than 0. And you know from quadratic equation, if d is greater than 0, it must have two unequal roots, real and unequal. If d equal to 0, it must have two real equal roots. If d less than 0, two imaginary roots. These are the cases. So let me explain that the previous thing, that is this, touches the circle, chord of a circle, and neither touches the circle. So let us explain this thing in a different way. If d greater than 0, line cuts the circle at two distinct points, and that is the chord. So what is the condition of the chord? Discriminant is greater than 0. And how we look at the discriminant? By solving the equation of the circle and the straight line, and you will get a quadratic. If d equal to 0, line touches the circle and it gives you the tangent to the circle. This is the condition for tangency. It will give you the equation of the condition for tangency. And d less than 0, neither cuts nor touches the circle. Imaginary tangents. So what is the condition of tangency? Discriminant equal to 0. If you get discriminant equal to 0, b square minus 4ac, you will get 1 plus m square into a square equal to c square. This is the very important condition, my dear students, for condition of tangency of a circle. This is the very important condition, that the line touches the circle, or line is a tangent to the circle. Y equal to mx plus c is a tangent to the circle x square plus y square is equal to a square. So this gives you the condition of tangency. You can get the condition of tangency for the general equation of circle also. Okay, so these are the important theoretical aspects of the circle chapter. I hope today's video lecture is clear to everybody, and follow my channel. I will give you more detailed discussions on conic sections. Okay, thank you all of you.